Hi, this is Philip Ekberg, and you're watching Game Programming with Python and PyGame. In this module, we're going to take a look at how we can start using PyGame in our Python applications. We're going to do that by exploring PyGame through different demos. Alright, so now we're inside PyCharm again, and all I've done here is that I've opened an empty directory on my disk that I called Module2. And I want to start off by creating a Hello World example in PyGame where I want the text Hello World to be displayed on screen. Now the first thing that we're going to do here is that we're going to create a new Python file inside this directory. So we're going to right click Module2 here and do new Python file, and I'm going to name this Hello World. Now let's just get rid of this here. In order for us to be able to use PyGame inside our applications, we need to import PyGame into our application. If you watched the previous module and you have PyGame installed on your machine, just simply write import PyGame. And now we can start using the classes and functions within PyGame. So the first thing I want to do here is that I want to initiate PyGame and simply just define that we're going to start using a PyGame application. And we do that by writing pygame.init. Pygame init will just initialize all the PyGame modules that is needed for us to actually write an application using PyGame. So let's just add pygame.init. And as you can see here, we're also getting some beautiful IntelliSense in PyCharm. Now, the next thing that I want to do here is that I want to show a window on my screen here. As I want to use PyGame to actually write a game, I can tell PyGame to initialize a new window or display a screen here with a given size. So let's first define the window size, and we can do that by writing window size is equal to, and I'm going to use a tuple here with two values. So the first value is going to be 800, and the next one is going to be 600, because I want this to be 800 by 600 pixels. Now we can set up the screen here that we want displayed. And we want to save a reference to that screen, because later on when we want to add things to the screen, like images or text, we need a reference to the screen so we know where to actually add these objects. So let's write screen is equal to pygame.display.setMode, and then we can supply the resolution. As you can see here, the resolution expects a tuple of two values. So we can do window size. Let's try to run this here and see what happens. So remember that I said before there's a shortcut to actually running applications within PyCharm. We can press Shift Alt and F10 to get a menu with the applications that we can run. And I want to run Hello World here. Now as you saw here, the screen just blinked here. So we had something show up, but then the application terminated. So the execution was done, right? So we simply just show the window, and when the window has shown, the application terminates, and that terminates the window. Before we go to the next step, I just want to briefly show you why we can include PyCharm this easily without actually doing any more hassle than just creating the new file and writing import PyGame. So after installing PyGame, I can go to my C:\Python and the include folder, and you'll see a directory called PyGame. So the files necessary for us to actually be able to include PyGame is installed within our reach of Python. So let's go back to the Python application again. Now let's try to actually make this run longer than just showing up on the screen and then just disappearing again. So in game programming, we often talk about the game loop. The game loop is a loop that runs infinitely until you decide to terminate the application. And we can simply do that by just writing while one. So that's the same thing as doing while true. This will run until the application is terminated. So let's add something to the body of the while loop here so that it has something to do while it runs indefinitely. Let's just call pygame.display.update, which will just update the screen with the new information that it might have gotten. So let's call this here and just run the application again. Now as you can see here, the window is showing for a bit longer. However, if we try to interact with this here, you're going to see that it tells us that it's not responding. And that's not really good, is it? So the reason for that is because every time we do something within our application, such as moving the mouse or pressing the keyboard, that's going to register an event in our collection of events. And if we don't go through all the events, this just start to grow, and that's really not a good thing. So we need to process all the events inside our application. However, at this time, we really don't want to do anything with either the mouse or the keyboard. Although there's actually one event that we really do want to focus on, and that's the event that tells us what's going to happen when Going back and actually looking at the code, you can see that there's really not that much of a fuss going on here. So simply we're just initializing PyGame, we're setting the window size, we're just loading a font and rendering a text using that font. And then we're simply just looking for whenever the user wants to exit the application and just showing the hello world text on the screen. It's as simple as that. And throughout this module, we're going to continue working on this code here and do some really interesting things, and seeing the hello world example evolve to something more interesting. We just saw how we can add some text printed onto the screen here, and how we can initialize and get started with PyGame. Now let's do something more interesting. In the previous demo, I talked about that we can get things moving on screen here. And pay close attention to the second parameter passed to the screen.blit method. That's the coordinates of where we want to show the text here. If we run this here, you're going to see that hello world is rendered in the top left corner. And if you recall the width and height of this application, we're using 800 by 600. So it's 800 pixels wide and 600 pixels high. That means that the bottom right corner is going to be the coordinates 800 by 600. And the top right corner is going to be 800, 0. And of course, the bottom left corner is going to be 0, 600. So let's go back to the application and see what we can do here that makes this a bit more interesting. So in each while loop here, we want to update the position of our hello world text. That means that we need to change these here to be updated on each iteration. So let's start off by breaking out the x and y by going up before the while loop and defining x and y is equal to 0, 0. That means that we're initializing two variables, both with the initial value of 0. Now let's go down here and actually replace the two zeros with x and y. And just verify that this still runs and looks the same. Right, so this works. Just to make it easy for us, we can simply just increment x down here with a given number of, for instance, 5. And you're going to see that this actually works. X is incremented and the hello world is actually moved. But it might not really look like what you expected. And surely enough, this really doesn't look like what we want, right? We can't really see that it says hello world anywhere. So let's go back and fix that. Maybe it actually moved too fast. So let's change this to a 1 instead and run the application again. And you saw that it just flashed by. There's a white line here, and we need to figure out why and how we can fix that. So the problem here is that we're just calling screen.blit each time that this loop iterates. And the problem is that the screen.blit method will just add this to screen and don't care about what else has been added to screen before. This means that we're not putting our hello world text onto a fresh new surface that is clean. We're putting it on the same surface as we wrote on the first time. There's a really simple way for us to actually fix this. We can simply call a method called screen.fill, and this takes the color that we want to fill the screen with. When this application starts, we want the screen to be black. So let's just supply this with the RGB code for black, and that's 3 zeros. So if we run this again, you're going to see a completely different results. However, it just blasts by and we can't really see anything. So is it really wrong for us to actually increment this with a 1 each time? In the previous demo, I talked about the game loop running fast on faster computers and slower on slower computers. So if you have a much faster computer than I have, you might not even see the text being rendered on the screen at all. And if we run this on a slower machine, you might actually see the text here. So there's a way to fix this. I'm guessing you've heard of frames per second, and that's exactly what we want to adapt here. So we want to ensure that our x variable is just updated every given frames per second. So let's say that after 40 frames per second, we want to update our screen again. And in PyGame, that's a really easy thing to do. We need to define something called a clock. And then we need to tell the clock to wait for a certain tick. We need to define the clock outside of the while loop. We simply do clock is equal to pygame.time.clock. And now we have an instance of a clock, and we can simply go down to our while loop again and add clock.tick and supply the frames per second. Clock.tick here is going to ensure us that the code below here just runs 40 times per second. If we run this again here, you're going to see a completely different result. y plus equal to 5 times direction y in this case, because we need to introduce one more variable that keeps track of the y position. So let's do that up here as well. Let's call this direction y, and this is going to be initialized with the 1 as well. And now we need to make sure that this doesn't come close to either the top of the screen or the bottom of the screen. And we can simply apply the almost exactly same if statement that we have down below here, but just changing the x here to y, and change hello world size to use the height instead of the width, and check that it's below 600 and not 800, and check that y is not below or equal 0. And then invert the direction of y. So if we run this here, you're going to see that this actually bounces quite nicely on top of our screen here. It doesn't go out on any sides. It bounces nicely on top, on bottom, on the left and right hand side. So in order for us to make this bounce around in both x and y position, we simply just had to make sure that the object is within the bounds of our window. And in this case, we actually used the constant values of 800 and 600. So by having this done in the direction of x, we could simply just copy and paste that and make it work for the y position as well. And things like this is something you're going to work a lot with if you write your own games, especially when you work with collision detection. This type of detection checks if we're within the bounds of something, but we could as well check if we're bouncing towards something else on the screen or if you're colliding with other objects on top of our screen. There's still a lot of things that we can add to our applications to actually make this much more interesting, such as having the text follow the mouse pointer or having it play a sound whenever it touches the walls. Things like this is something that we can add later on in this module. But for now, we've seen how we can initialize PyGame, get some text printed onto the screen, and getting this text actually bouncing towards all the walls in our application, and making sure that it doesn't really go outside of those bounds. So far we've seen how we can fire up a new PyGame application, and inside this PyGame application we render some text that we later on made bounce around on the walls inside our application. And we made sure that the text did not go outside of the bounds of the application. Instead of having the text bounce around on its own, we want to be able to interact with this application using our mouse. So instead of having the x and y coordinates incremented by the given number of 5, we're instead going to use the mouse position. So let's go down inside our game loop here and remove some of the code inside here that we want to replace with using the mouse pointer instead. So let's get rid of the if statements and the increments here. PyGame makes it really easy for us to use the mouse and keyboard. And to get the position of the mouse pointer inside our application, we can simply call pygame.mouse.getPosition. So let's store the x and y coordinates for the mouse position in a variable that we call mouse position. And this is going to be equal to pygame.mouse.get_pos, which is short for position. And now we have a top layer of the x and y coordinates for the mouse position. And we can simply set our x and y coordinates for our hello world text by doing x, y is equal to mouse position. This will simply take the first value in the tuple and set x to that, and then take the second value in the tuple and set y to that. And if we run this here, you'll see that the hello world text will in fact follow our mouse pointer. However, notice what happens when we get nearer to the edges of the application. For instance, if we move the mouse pointer over to the right-hand side, you'll see that we're in fact having the same problems as we had before when we bounced around the hello world text inside our application. You'll see that the text hello world is now outside of bounds of the application. Instead, what we want to do here is that when this approaches the edge of the screen, we want to set the position to be at the very edge of the screen here. So let's go back to the code and fix that. And the way we fix this is similar to what we had before when this bounced around. So we need to make sure that the x coordinates plus the hello world size and the y coordinates plus the hello world size is not outside of the bounds of the application. Let's start with the x position first. So we want to check if x plus the hello world's width is larger than 800. And if it is, we want to set it to the furthest position to the right that we want to allow. To do that, we do if x plus the hello world size, and we use the first value that indicates the width. And now we check if this is over 800, which is the width of our your games. So let's get rid of the mouse pointer. And just as we got the mouse position by calling pygame.mouse.getPosition, we can use pygame.mouse to do other things with the mouse as well. So we can add a method call down here to essentially just set the mouse pointer to be invisible by calling pygame.mouse.setVisible and supply this with the true or false value to indicate if we want to show the mouse pointer or if we want to hide the mouse pointer. And I want to hide the mouse pointer. Now that I run the application, you'll see that there's no mouse pointer inside our application anymore. And we can move around here and this looks really nice. And moving the PS circle towards the edges of the application, we'll still have it within the bounds of the application. That's because we use the hello world size variable that simply retrieves the size of our loaded image. Now let's see how we can introduce some sound in our application. When we start our PyGame application, we call pygame.init to initialize the modules that helps us work with our application. However, to work with sound, we need to initialize our mixer as well, which we use to both load and play sound. So let's go up here where we do pygame init and simply call pygame.mixer.init to initialize the sound mixer. And as you see here, we can supply this with different parameters, but in our case, let's just use the default values. And now we have our mixer initialized, so we can use the mixer to load sounds and to play sounds. And loading the sound is equal to loading an image. So let's go down here and simply create a new variable that we call sound. And this will be the variable that we use to play our Pluralsight audio file. So we'll set this to be equal to pygame.mixer.sound. And we use this here to tell it to load a sound file from our disk. So we need to supply this with the file name of our audio file, which is pluralsight.wav. Just to make a small note here, when we're going to move over to create our entire game later, we're going to have a much better structure of where we load our assets, such as the images and sounds. But for now, let's continue working with this simple example here. So let's go down to our game loop and add somewhere where we want to play this sound. So I want to play this sound here whenever we hit the wall. And we simply play the sound by doing sound.play. And we can supply play with some variables as well. Let's just keep the default values. And then we can do the same thing when we hit the bottom of the application. There's one more thing that I like to add though. When we call sound.play, we want to ensure that the sound isn't already playing. So we also want to add sound.stop to ensure that it in fact isn't already playing. So let's copy this and paste it down here as well. Now when we run our application and we hit the walls, you'll hear that it actually plays the sound that we loaded from our sound file. Pluralsight. As you might have noticed, when we hit the top of the application or the left-hand side of the application, it didn't play the sound file. And that's because we don't check if x or y is equal to 0. So what we need to do is that we need to add another if statement that just checks if x or y is equal to 0, and if they are, we need to play the sound file. We simply do that by doing if x is equal to 0 or if y is equal to 0, we want to play the sound file. So we can simply copy and paste these two here and paste that down here. Now when we run the application again, you'll see that when we hit the left-hand side of the application or the top of the application, it should play the sound file. Pluralsight. So we now verified that when we run the application and hit the left-hand side, when we hit the right-hand side, when we hit the top or the bottom, it plays the sound file. So now you saw how we can change the very simple text that we had rendered onto our screen to become an image instead, and how we can remove the mouse pointer from our application to make it look even better, and also how we can play some sound inside our games with the things that we've started to look at, such as using the mouse position, using images and using sound inside our application. we can move on to look at even more complex things. Before we start looking at how we can create our game though, we're going to take a look at one more type of input that we might want to use inside our PyGame applications. We've listened to the mouse input and retrieved the mouse position.